Yeah. Yes. Now let me start with my screen. Yeah, screenshot sharing is started. And,
Yes, so your presentation is present on the screen. Yes, you may start your presentation, please.
yes, I want to, yeah, here. Hello, everyone. My name is Wan Tiansen, and the paper I present is from prompting and output evaluation in ChatGPT for teaching and learning, a review of empirical studies use machine learning. And for the first part, I will introduce some background information to help you quick understand this topic. Um, as we know, to effectively assist working and learning using human-like language to train large language models output, and uh, this can be called prompting, has been a potentially significant design technique for non-AI experts. And as a new type of skills needed to be acquired, prompt engineering or prompt design, prompt programming, or prompting is iterative and interactive art of co-creation between humans and the AI. And from the human-computer interaction researcher's perspective, lack of guidance, representation of tasks and efforts, and generalization of prompts are challenges of interactive use of prompting. Therefore, it's important to glean practice experience and lessons from existing prompting usage articles. And based on that background information, we can see for non-AI experts, there are some prompt features, components, or strategies to be referred to. However, the question is the proposed prompting techniques are too abstract, and it is hard to guide non-AI experts or beginners to implement these strategies in their own actual practice. Therefore, in this study, we try to have a review of the prompt strategies and their usage scenarios to present examples to non-AI experts and beginners about whether they are existing prompt cases similar to their problems, and to help them develop their own prompts and evaluate the quality of ChatGPT outputs. To make a contribute to the prompting construction of ChatGPT in education, two research questions that is this review research question. One is, what is the performance of a test classification techniques to identify empirical studies with and without detailed prompts? And research question two, what prompting features can be found in the teaching and learning context? As of As a review article, this research followed the PRISMA guidelines in research review, and two database was used, Web of Science and Scopes. And for the search string, there are two paths. First is ChatGPT or GPT or chatbot or Bing or bot or Copilot. And then the next other part is learn or edu or train or teach. After the round of for test reading, at the end, it were 102 empirical articles left. And for the further research methods, we have three kind of methods used. The first is prompt features clustering. We use the key prototype clustering algorithm to cluster the coding results. And to find the optical key, we use the elbow method. And we also use machine learning and natural language processing model training and evaluation. This part I will introduce later. Third one is visualization of the empirical studies with prompt details to better visualize the highly frequent terms of empirical studies with prompt details in education, what cloud was employed. And for the code schemes we used for this article, generally there are three parts. The first is about category of ChatGPT in teaching and learning stages. Based on biggest pre-stage process product model of teaching and learning, we divide the selected articles into three stages, namely pre-stage, process, and product. And for the prompting features, after comparing multiple prompting features or strategies analysis framework, which was tailored by Center and Phone, it's a general taxonomy of LLM prompts that are as the framework to analyze the prompt types and details. The tailor categorizes LM prompts from four dimensions, namely tone, whether it's single or multi-tone, expression, whether it is question style or instruction style, or rule, whether the system will assign a rule or not, and the details of the levels of details, including 0 to 6 levels. And for the output evaluation methods, we use a bottom-up method to synthesize the six measures, including bottom-up analysis, general-based evaluation rubric, domain-based evaluation rubric, machine learning evaluation rubric, user perceptions, and learning performance. And for the result, we found, as shown in the table 2, we chose both term frequency, inverse document frequency, and biograms to do feature embedding to transfer text into number vector. And then the results can be fed into classifiers, including naive bayes, random forest, k nearest neighbors, logistic regression, support vector machine, XGBoost algorithms. And based on the traditional machine learning evaluation metrics, it was found that the combination of biograms and the naive bayes, or TF-IDF, and support vector machine output with accuracy nearly 0.73. And for the frequently used terms, we found besides the commonly used words like ChatGPT, student study, potential, and education, some differences can be found between the articles with prompt details and the articles with and without prompt details. For articles with prompt details, feedback, prompt, LAM, response assessment, quality, and performance appeared more frequently. And for the general articles with or without prompt details, use at all, learn, research, impact, artificial intelligence, and AI operate frequently in the corpus. And for the clustering results, we found 6 clusters. These clusters, each teaching and learning stages have 2 clusters. These 6 clusters largely reduce the information loss from our datasets. For the discussions and conclusions, for further explore the datasets motion, we found machine learning and natural language processing techniques can be used to automatically identify empirical studies with prompt details and without prompt details in ChatGPT in education. What clause can be drawn to explore the high frequency terms. And based on the analysis framework, combine biggest presence process product model of teaching and learning, and a general taxonomy of LM prompts tailored by Center and Phone, and the numerical results of ChatGPT article articles evaluation methods, 6 groups were generated using a clustering algorithm, and it was found that bottom-up general evaluation rubrics, domain evaluation rubrics, machine learning evaluation metrics, user perceptions, and learning performance are the commonly used ChatGPT articles evaluation methods. And for the implementation, it can be divided into 2 parts for researchers. For the researchers, a low frequency transparency of AI tools might be related to practical and ethical issues of their implementation in real society, for which explainable and human-centered AI is called for meaningful and impactful educational technology, including human-in-the-loop components in previous stage studies might be one potential solution, which could be hard at the beginning, but the continuous new data sets from real life will be collected. And for research methods in review writing, benefit from the development of NLP and LLMs techniques. More articles can be included in the review process to help understand the big picture of a field. Using clustering, several clustered group can be generated, and based on this, researchers can comparatively be easier to find the similarities and differences among the included articles. Using NLP, the test data can be developed into a corpus and explored further from the frequency of items and semantic similarities of the sentence lab aspects. And even for the excluded articles, the data from them is also a kind of complementary information for the topical one review explored. And thanks for your attention. It's my PV.
Thank you. Thank you, Wenting, for your